So the second video for Pythagorean Theorem is talking about distance between 2 points using the distance formula and if something actually is a right triangle. So what I want you to think about first is a triangle with these side lengths, 31, 21, and 20, and 31 would be the hypotenuse. Is it actually a right triangle? Okay, so what do we know about right triangles? We know that there's a formula, a squared plus b squared equals c squared. And if this is true, then it's a right triangle. So let's check it out. 20 squared plus 21 squared equals 31 squared. And 20 squared is 400. 21 squared is 441. So when I add those up, that's 841. Is 31 squared going to be 841? And it's actually 961. So it's not equal. And because it's not equal, this is not a right triangle. So A and B are your legs. We saw that last time. C is the hypotenuse, and the hypotenuse is always across from the right angle. So we did if a squared plus b squared equals c squared, then right triangle. Well, the converse statement of that is if right triangle, then a squared plus b squared equals c squared. And it works both ways. A right triangle will always have a squared plus b squared equals c squared. And you can think about that working forwards and backwards. So what if it's not a squared plus b squared equals c squared? If a squared plus b squared is bigger than c squared, it's an obtuse triangle. Going back here, a squared plus b squared was actually less than. So we're looking at this third example. If a squared plus b squared is less than c squared, then it's an acute triangle. So the triangle we actually had with side lengths of 20, 21, and 31 is actually an acute triangle. So determine if a triangle with these side lengths is a right triangle. And if it's not, is it acute or obtuse? So a squared plus b squared equals c squared. Notice how I put 12, the biggest side, as the hypotenuse. 25 plus 121 equals 144. So is that true? 25 plus 121 is 146. That's not equal to 144. And since a squared plus b squared is greater than 144, this is an obtuse triangle. So, distance formula. Where did it come from? We've seen distance formula before. We've all used distance formula before. So as we do this, let's pick two random points. I'm going to pick -3, -1, and 2, 4. Okay, and I'm going to call those A and B. And if I draw the segment between those, it's a straight line distance. So what I want to do is I want to draw dotted lines there and there. If you look at just the vertical and horizontal components, it forms a right triangle. Your height is how far did I start from my y down to my y, and how far left and right do I go. So this part right here we could look at as A, this part right here we could look at as B, and the distance from one to the other is the hypotenuse C. So if I take a squared plus b squared equals c squared, and I get c by itself, I take the square root of the other side. The distance formula is a fancy version of Pythagorean Theorem. It's using a graph and two specific points. So find AB if these are the coordinates. So we could use distance formula because we don't have a graph here. As you're getting more and more comfortable, you may want to label these just so we know what we're doing. x2 minus x1 plus y2 minus y1. Be very careful with negative signs here. That's one of the most common mistakes. 5 minus 2 is 3, so we have 3 squared plus, minus a negative is a plus, so that's 1 squared. So 3 squared is 10, or 9. 1 squared is 1. That's where I was getting 10 from. 9 plus 1 is 10. So the distance between these two is the square root of 10. And that will not simplify because the only factors of 10 are 5 and 2. So now let's look at another one. Find the distance between these 2 points. We could use distance formula again. Label them x1, y1, x2, y2. 5 minus 9 squared plus negative 4 minus negative 1 squared. 5 minus 9 is negative 4. Notice how I'm putting it in parentheses because negative 4 squared is much different than 4 squared, or negative 4 squared. These parentheses actually take that negative and change it to a positive. Negative 4 minus a negative, or plus, is negative 3 squared. So this distance, negative 4 squared is 16, negative 3 squared is 9. So 16 plus 9 is 25, and the square root of 25 is 5. So the distance between these 2 points is 5. Now we have a graph. I have the points listed, same type of example as the previous 2, but because I have a graph, I'm going to draw in my horizontal component and my vertical component. What makes this a little bit easier now, because distance formula really is Pythagorean theorem, I can just count these because they're horizontal and vertical. 1, 2, 3, 4, 5, and up 1, 2, 3. So I have an x component of 5 and a y component of 3. 5 squared plus 3 squared equals, let's call that x squared. When I have a graph, I can just do Pythagorean theorem. 25 plus 9 equals x squared. 25 plus 9 is 34. So the distance between those is the square root of 34. Now if I did distance formula, I would get square root of 34. It might take a little bit longer because I'd have to do 2 minus negative 3 and 6 minus 3, but we still get 5 and 3 when we do those subtractions. So keep in mind that you can use distance formula and Pythagorean theorem interchangeably.